the second part of our simple project, in which we can see how students can learn about the microstructure and phase diagram of this material using the phase diagram section of the database. And then we are going to jump into the property process profiles to see how students can learn about the effect of different processes on the properties of specific materials. So let's jump back to the software, and we can go to the wheel of MSNE database. And so, as I mentioned, we can use the phase diagram section to learn more about different concepts associated with phase diagrams and atomic arrangement and microstructure of materials. So if I click on that, you can see that we have 5 interactive tools available here. And in the interest of time, I will be only showcasing 2 of these. So the first one that we will be going through is the lever rule interactive tool. So if I click on that, you can see that we have included here a brief description and a simple derivation of the lever rule. And by clicking on the tab, students would be able to calm down the temperature. And within the mushy zone, they would be able to see how in action the lever rule determines the weight fraction of each of these phases. So by calming down the temperature, the composition and weight fraction of these phases changes, and lever rule is the concept that is determining that fact. So they would also be able to see the schematic that is on the right-hand side of the phase diagram with a brief description, and they would be able to see how with decreasing the temperature, the amount of solid phase increases and the amount of liquid phase decreases, and how the composition actually changes as well. So this interactive tool can be very helpful to visually teach students about how the lever rule actually works in action. The second tool that I want to show you is what we call the phases tool. And as you can see in here, we have included 3 of the most commonly used binary phase diagrams when educators are teaching students about essentially the concepts of phase diagrams. So I'm going to be using the iron carbon one. And so as you can see in here, when students hover their cursors on any area of the phase diagram, the atomic arrangement available in that area is shown in the schematic on the right-hand side with a brief description. So for example, when we go to the mushy zone in liquid plus austenite phase, we have the solidification front shown in the schematic, as well as the atoms freely mixing in the liquid side of things on the right-hand side of the schematic, and the FCC microstructure of the austenite on the left-hand side of the schematic. So students would be able to easily compare, for example, the packing density in an FCC microstructure in austenite with the packing density in the BCC microstructure, which would be available in the ferrite phase in this phase diagram. So we have that information for perlite, cementite, and the delta iron as well. So that's the 2 tools that I wanted to show you in this regard. Let's go back to the chart and see how students can actually learn about the effect of different processes on the properties of materials. So for this, we are going to be using the section that we call property process profiles.